Okay, in this video we're going to dive into the range function a little bit in Python 3 and talk about how it works, why we need it. So first of all, let's do a little memory test. Okay, I'm going to make a file here called memory .py. Okay, and when we think about making the range function, we usually use it in a loop, right? I can say for I in range 10. And I can print out some value I, or I can do something 10 different times, right? Because that's what this does. The idea conceptually when we talk about this, we think of this as creating a list of items, and then I iterates over them one at a time, right? We can also have a loop that is, let's change this to 5 so it's a little easier on me typing. We can have something that's effectively equivalent, I in, and then a list of items, 0, 1, 2, 3, 4. Right? So we know this works effectively the same way, right? Or we think we do anyway, right? Both of these things run and produce the same results. So we can run these, Python 3, memory. Okay, and we go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. All right, so effectively we might think that these are doing the exact same thing. Range just produces a list like this, right? But we have also probably noticed that, I'll open Python 3 in interactive mode here. If I call the range function, right, I don't get a list, right? That's not what this is, right? We have a range object, right? I can look at this. What is the type of calling the range function? Right? It's a class. It's an object range. Okay, that's different than a list. What is the type of the list that is 0, 1, 2, 3, 4? Right? That's a type list. So they're different. What is different about them? Well, with the list, we can convert a range object into a list using the list function. Right? And if we do this, then we actually do get a list back. Okay, so there's some subtle distinction between conceptually what we see going on here and you know what we think might be happening versus what is actually happening in Python. Okay, so the reason for this is, like in most things in computer science, there's some sort of trade-off that has to take place here. Now, this style of for loop where you have a variable and it iterates one item after the next. First of all, what is iteration? Right? Iteration is something that you can do to an ordered collection. So ordered means it has a beginning, and you can incrementally get through the entire collection, unless it's an infinite collection. You can iterate through every item of it. Okay, so it has a start, and it has, it doesn't necessarily have to have an end, most of them do, but you can iterate through all of the items in the list, and you won't get duplicates, you won't reoccur on certain iterations, right? Because that would be sort of a looping pattern. So this idea of the for loop, we're creating a variable, and so we see that lists are iterable because they're ordered collections. They have a beginning, and in this case they have an end, right? So I can go one, then the next, then the next, then the next, then the next, till it's all finished, right? So what makes range different? Okay, well, one thing is, if I have this list in Python, all of these items in the list have to exist in memory somewhere, right? There are indeed there's a value of 0 somewhere. There's a value 3 somewhere stored in memory, right? I could make this list because these could be anything. I could have these be, you know, the number 100, number 200, right? So these values are stored somewhere. And so if I just make the list, then instead of the loop just running one time, or just getting one of these values each time, I have to store this entire list, right? So we can do something similar. Let's add some qualifications here. This is the for range, and then this is the for list. And then we'll add a while loop that can do the same thing, right? So while loops are your most powerful loop. You just have to do some extra stuff. The syntax sometimes is longer. So we don't need a list here. This is just a while loop. So with the while loop, we're going to get effectively the same behavior, but we don't have to have this entire list in memory, right? So we have some I value, and we're going to start it with 0. And we're going to say while I is less than some, ending point, and our ending point up here was 5, and that's essentially what our ending point is here, right? So we'll say end equals 5. So while I is less than our ending point, we're just going to print I. But then at the end of each loop, we have to increment, right? So we're going to increment I plus equals 1. All right, and that's sort of, effectively what's happening in the range function, right? We have a starting point. So if you don't provide the starting value, if you only provide one value to the range function, that's the ending value. You can provide two values, and this would be the starting point and then the ending point. And remember, the ending point is never included in the resultant list if you were to pass this to a list function, right? And then you could also pass in the increment or the step, and by default that's 1. So if I don't provide the starting point or the increment, right, this is just the ending point. And effectively, we sort of get a list like this, but without the memory overhead. So we're not actually generating the whole list at once. Instead, we're doing something like this. So notice with this while loop, we never have all of the items for I in memory, ever, right? We always have one item, and then we add to it. So the memory footprint of this is much smaller, right? We've got a starting point, an ending point, right? And then we just add our increment, whatever our increment value. So this might be step. We'll say that's 1, and we're just going to add step. Okay, so we still get the same result, but the memory footprint is smaller. Here we have to keep 5 values, right? Here we don't. Well, that might seem negligible, right? That seems like, well, that's not that much, right? So let's just run this real quick and verify. So all 3 of these loops are doing roughly the same thing, but in slightly different ways, right? So let's take a look at the memory footprint of something more substantial. Okay, so let's make a range object. That is range, and we're going to have a really big number here. So I have 16 gigabytes of memory on this computer. Okay, so I'm going to make, if you don't have this much memory, you probably don't want to do this. We're approaching a situation where we're using more memory than the computer might have. So be careful with this. You might start smaller. But I tested this beforehand, and this works for my machine. I have 500,000, and that's 500 million. 1, 2, 3, 1, 2, 3, 500 million. Okay, so we have a range object. Now up here, I'm using Ubuntu Linux, and I've got a system resources, my system resources displayed up here. And here we have, this is CPU processor. I've got 8 cores, and we're recording right now, so there's some spikes. But here is the memory, right? And it's relatively low, considering I've got 16 gigabytes used, okay? And so if I run this program, we have the range function here. And remember, this is effectively sort of simulating this idea of a list, okay? And we're going to see if this jumps up in any memory usage, okay? And one thing we want to do here is this program is going to stop right after we generate this object, and so we might not have enough time to see the actual memory usage go up. So we're going to use a little library here called time, import time, and then at the end of our program we're going to say time.sleep and specify how many seconds that we want to sleep in here. So we're going to sleep for 5 seconds, and that's just so that we can see the system resources go up, if any go up, right? So this is memory tests. This is the range. All right, and we can run this again. And we see the loops run really quickly, right? And look up here. All right, a program ended after 5 seconds and almost no spike, right? Well, let's make this a list test instead. Okay, so we know we can use the list function on a range object. Okay, and so this is it's our list now. Okay, and we're going to generate this list, and now we're going to keep an eye on this memory. All right, these three loops are pretty much negligible, so they'll run real fast. We don't have to really worry about that. But now here we're building the list. Now look up here. We have this ramp. We are increasing our memory. Right, we haven't even gotten to the sleep statement yet because Python's still building this list. Okay, and once we get to a peak value where all of the list items are created, we see this levels off. Okay, and now that list is stored in this variable, right? And so it's just stored in memory. We're using that memory right now. Okay, now here's where the program ends, and Python deallocates all of the memory in use for the program. Right, that memory is no longer used, and so there's a process where Python goes through and frees up that memory. All right. Now, one thing, the most important thing you take away from this is there's a massive difference between generating an entire list versus generating a range object. And the range object allows us to one at a time calculate these values. Right? So I can calculate one value after the next. Now, the benefit of having the item in the list is that I can access any one of those items very quickly by reference by index. Whereas with an iterable, I might have to iterate from the beginning all the way to the end, right, to get the final object, right, which might be more processor power. The range function actually is a mix of ideas, and you can index the value. Just specifically by the nature of the range, we can use mathematics to very quickly get the value that we want, because the items in a range function aren't just random, right? They follow a mathematical pattern. So it has some niceties that just an average list wouldn't. So if I have a list with just random things in it, I can't necessarily calculate what the next one will be, right? But with range, it follows a arithmetic pattern, right? So we can. But the main takeaway here is when we generate the list, it takes a massive amount of memory. Okay, so actually Python 2, the range function, did just return lists. So when you called the range function, it didn't ever just return that range object. It returned an actual list. And that was, for most things, is pretty useful. But when you start getting into very large lists, it becomes problematic. All right, so another thing we noticed, this is probably the second most important thing to take away from this. We have this list object, and we're storing it in memory, right? And we saw the memory go up and then sort of plateau, right? And then go down. Now I'm going to do something here. I'm going to not store this list in memory or in a variable. Okay? So this list, I'm just going to generate the list, and Python will generate this list in memory, right? But once it's generated, I'm not going to store it anywhere. And we're gonna take a look at the difference here. And we're still sleeping for 5 seconds, just like we were, okay, at the end of the program. So here we go up. We're ramping up our memory. We're approaching our plateau. Okay. Now notice it didn't plateau this time. We just see the memory going back down. Okay, that's because Python has a garbage collector. And the garbage collector is basically a memory manager, and it detects if there's any Python identifiers associated with items in memory. If we no longer have a way to reference the thing in memory, like in this case, I just created the list, but then I didn't store it anywhere. So if I no longer have a way to access it, it's as good as useless. So Python will automatically remove this from memory. So we see that we don't have that plateau because we don't have this stored in a variable. So Python is smart and immediately deletes it as soon as it's no longer referenceable. So as soon as you no longer have a way to access that. Now there are a couple of exceptions to this. You can get in situations where you have data locked in memory and you have no way to access it. But for the most part, the garbage collector is very intelligent, and as soon as you no longer have a reference to that data, the garbage collector comes through, and it's a good name for it, right? What is garbage in terms of, you know, human consumption? It's things we no longer have a need for, right? And so we want to get rid of them so we have space, right? That's the same thing with this memory. Okay, so you always want space. You always want free memory. I don't want just something sitting around in memory taking up space if I'm not even able to use it, right? So garbage collection is an important aspect of most programming languages. Not all programming languages have garbage collection where you automatically where things are automatically removed from memory. Okay, so garbage collection is a feature of a language, and again, not every language supports garbage collection, but it's nice because you don't have to think about explicitly storing something or removing it from memory in Python. Just whenever you can no longer reference it, the garbage collector comes through and removes it. All right? So that's sort of the key difference between the range function and iterating over a list. Okay, so the range function is iterable, right? And it's not an iterator. But it's iterable, meaning it has a beginning and you can go one item at a time and either eventually go on forever or reach the end, right? So it's an ordered collection, right? That's the idea. So we can create an iterator and iterate through it. Okay, so the next video we're gonna discuss a little bit about an iterator and what that actually means.